Question 22. On the picture shown, Kan wants to add some line segment such that each of the 7 points have the same number of connections to the other points. What is the least number of line segment Kan must draw? Such a thing is usually called a graph. The points, they are called vertices in graph theory. And the line segment are called edges. And the connection is called degree of a vertex. So this one got 3 connection. So degree is 3 like that. This one got 2 connection. So degree is 2. The rest got 1 connection. Degree is 1. So we have 7 points and must have the same number of connection. Since this one is 3 connection, we want the least number. We must try to get all 3 connection. Every point 3 connection. See can or not? You will find if every point got 3 connection, 7 points must have 21 connection. This point is 3. Then you go add one more, 3. Every point 3, 3, 3. 7 times 3, 21 connection. But one line segment always join 2 points. That means one line segment create 2 connection. Like say this line, it create 2 connection. To join to 2 points. So if one line is 2 connection, then 10 lines, 20 connection. That means connection is always even. The total number of connection is always even because every line give 2 connection. Odd numbers like 10, 11 line segment must have 22 connection. So if we want every point to have 3 connection, it's not possible because we end up 21 connection. Let's show some line segment first. So I have 3 connection, 3 connection, 3 connection, 3 connection, 3 connection, 3 connection. Now this one 2 connection. If I join, then the number of connection will be 4 already. We want same number of connection. So 3 connection is not possible. That means you must use 4 connection every point. Every connection has 2 endpoints. Every line segment has 2 endpoints. Okay, not every connection. Every line segment has 2 endpoints. So 2 endpoints. The endpoint are the number of lines is called the connection. There are like 3 connection. So 2 endpoints, then number of connection is even. Every line 2 connection. Another line 2 connection. Total even. Number of connection even. So you want to have 3 connection. Every point 3 connection. To have same number. Not possible. So it is not possible for every vertex to have 3 connection because the total number of connection must be even. So every point must have 4 connections. No? We want the least, so we don't increase a lot. Increase by 1. Then 7 points will have 28 connections. But each line contribute 2 connections. So there must be 14 lines. 14 lines, 28 connections. Then the picture already has 5 line segments. Therefore, we add at least 9 line segments must be drawn. 9 plus 5, 14. Answer is 9. This user's reasoning is better than try and error. You can try, oh, I add 4 lines, cannot get the answer. I add 5 lines, cannot. Add 6, cannot. Then you find, 9 can. Then this is the least already, so you don't have to try to get 10. But the reason is, you have 7 points, you then only can have even number of connection. So 28 connection divided by 2, 14 lines. 14 lines. So you add 9 lines. So this is a graph theory, Total degree of a graph is even. Total degree of a graph is even, means total number of connection must be even. Because one edge always 2 degree, 2 endpoints, 2 degree. We will look at one puzzle. Okay, this puzzle find a complete path where each segment is traversed exactly once. Points can be crossed multiple times, more than once, but segment only once. So where to start, so that you will go through every segment only once, traverse only one. So there are so many points, how to know where to start. So what is the reasoning, And you must start with the point with odd number of edges, 3 edges. Okay, because once you go out, later you come in, you can go out again. The end point also must be odd number, like this one, odd number. If you pass by already, later you come back, end here, finish, end here. No need to go out anymore. If you have 4 points, you come in, go out, you come in, you have to go out again. So end point and starting point must be odd. So the person who create this don't want people to say like, do try and error, so many points to choose. But actually, if you know the principle, you choose the odd number to start. So let's start. We start. 1, 2, 3, 4, 5, 6, 7, 8 already. Come to 8. Then you continue. 8, then 9, 10, 11, 12, 13, then 14, 15, 16, 17, then we turn out 18, 19, 20, and then don't go this way, then 21, 22, 22, and 23, 24, 25, 26, and 7. Then 28, 29, 30, 31, 32, 33, 33, then you go here, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43. 3 area. 43, come back, 44, 45, 46, 47, then 48, 49. If you know the trick, you won't spoil the chance over here at 21. You don't take the wrong turn. This puzzle quite a lot in the internet. Download from internet. You call semi-Eulerian graph. 2 odd vertices only. The rest must be even number of vertices. Okay. Then we look at the origin of graph theory. The origin of graph theory. The mathematician who discovered or invented graph theory is Leonhard Euler. What makes him discover is the map of Königsberg. Königsberg is a town in Prussia. Now the name changed already. Königsberg is now Kalinaberg. And it's in Russia. Russia. Kaliningrad, sorry. Kaliningrad. Kaliningrad, I think. So this place got 7 bridges. 1, 2, 3, 4, 5, 6, 7 bridges. Then you got 4 land masses separated by the river Pregel. The river is Pregel River. So 1 island and then 3 other land masses. Then the people in Königsberg always arguing, how can we walk every bridge at least once and then come back to the starting point. So everybody try to a solution and nobody can find any solution. So Leonhard Euler was thinking how to solve the problem. So he created a diagram like this. He first labeled the 4 land masses A, B, C, D. Then he convert it into this diagram. A is in the center. It has 2 bridges connected to D, another 2 connected to B. And then A is connected to C by 1 bridge. And then C is connected to B and D by 1 bridge each. So the bridge are the edges. Then the points are the land masses. They call vertices. So Euler explained that every point has odd number of edges. 3, this one 5, this one 3, this one 3. So if you go in, come out again, later you move, you go in, you cannot come out. So it's as simple as that. He's explained that therefore there's no such solution. You go in, you can never be able to walk all the bridges exactly once. You have to repeat. Once you go in, come out. Later you go in, you no age to come out. The bridge already used. So that is the origin of graph theory. Graph theory has some application, but we will go to the next question. Let me see this here. Oh, let me close everything first. I forget to close. one at a time so that it's not confusing. The question is, the picture shows the same cube from two different views. The two cubes are the same, but different view. It is built from 27 small cubes. Some of them are gray, some are white. What is the largest number of gray cube there could be? So you want to count the number of gray cube, especially the hidden one. The hidden one, you want to have more gray so that you can get largest. Strategy is make more gray cube so that we have largest. Then how to simplify the reasoning? That's what you all should be always asking. So after a while, you will say, okay, I count layer by layer. So you count the top layer. Top layer got 9 cubes. 9 cubes, you can see all 9 cubes are visible. So definitely only 2 gray, 7 white. Cannot have extra, can see, but all can see, so it's obvious. Now we go second layer. Second layer. And so you want to plan your thinking. If you can think of this diagram, this is the second layer. One for the first view, one for the second view. So the first view got 1 gray can see, and then 4 white, 1 gray, 4 white. So we say 5 cubes are visible. 1, 2, 3, 4, 5. So 4 cubes are hidden. 4 cubes are hidden. S. So we show, okay, this gray one in the middle, this one this is a gray one, second layer this one. So on the left got 1 white, then here 3 white, white like that. Now we look at the top, only 2 gray, so it means it turn 90 degrees. Second view is you turn the cube 90 degrees. So first we turn this gray, turn to here 90 degrees. So the 3 white is in front already, white. So this corner is white, so only 2 more new white, on the right side. Okay. Like that. Turn already. This one, turn. So these 2 we see now is here, white. So the rest hidden. Center definitely hidden. So center sure gray. We want more gray, so center we sure put gray. Then this one hidden, we don't know, we also choose gray, so we can have largest number of gray. The 2 gray like that. If we turn back the cube, then the 2 gray will be over this side. 2 gray. This one we cannot see. Here white, here white. Okay. White, gray, white. Though behind you cannot see, so we want it to be gray. So we can have total 3 gray. 3 gray. Here 1, 2, 3. 3 gray. Total 3 gray. Now we go to the third view. We again prepare for the third layer, bottom layer. So bottom layer, second view, show opposite corner, gray and gray. So we have 5 white, How to have 5 white? Uh, 1, 2, here 3 already, 3. Let me show my diagram. Okay, 4 white, I think, gray and then white, yeah. Then we know opposite corner must be gray, yeah. So when you turn already, opposite corner must be gray. So just now, here 4 white already, 4 white already. Okay, then this gray here show another new white, new white here. So that's why I say 5 white. 5 white means maximum 4 gray. Already got 2 gray, add 2 more gray. 2 more gray, okay. Then the 2 more gray here, so this one is already gray. So 4 gray, 4 gray, 2 plus 3 plus 4, 2 plus 3 plus 4, 9 gray. The answer is not important to the main thing. It's not the main thing. Main thing is how you create a solution. So first, you tackle layer by layer. That's the make the what called easier to show your answer already. That's the important. Then you draw squares like that to label. So the method, drawing is also part of the method. So you must be willing in the exam. Don't just content. Just keep thinking from the diagram. Count here. Plan things like that. Draw layer by layer. Then you develop your what I call way of solving. Willing to explore from different using different ideas. Okay, next question. Let's see this guy here. This guy is still not here. On an island, frogs are always either green or blue. The number of blue frogs are increased by 60%, while the number of green frogs decreased by 60%. It turns out the new ratio of blue frogs and green frogs is the same as in the previous ratio in opposite order. At first, blue to green, now green to blue, opposite order, same ratio. By what percentage did the overall number of frogs change? So we organize the information. That's another way of doing question. Organize by writing out. Okay, blue frog B, green frog is G. Then after increase 60%, so 1.6 blue frog. Then green frog decreased by 60%. So now only 40% left. Decreased by 60, so 40 left. 0.4 G. Like that, 0.4 G. Then new ratio, green to blue, new ratio is 1.6 to 0.4 G. Okay, green to blue, new ratio. It's a new number after the changes. So just cross multiply. Then G square is 4b square. So positive, so no plus minus. So question asks for what percentages did the overall number of frog change. Frog change is 60% decrease and what? Number decreased by 60%. A change by 0.6. This one changed by 0.4, correct? Number of green frog decreased by 60. Green one by 60. Let's see what did I do after that. Blue plus green is 3b percentage. So my answer not inside here, you know, 60 wrong already. So because of this error, this what percentage on overall change? So this one changed 60%. This one also changed 60%, drop to 60%. So 0.6. So 1.8. 1.2 plus 0.6, 1.8. Okay. 1.8b over 3, 60. By what percentage did the overall number of frog change? Overall number of frog change. Overall total frog is 3 blue because green is twice blue. Then increase by 60% and decrease by 60%. 1.8. You have to understand the change. What percentage did the overall number of frog change? Overall number of frog change. 60 change. 60 change, decrease 60. We move on to the next question. Perhaps you can I got send you the answer. Where's the answer? Let me look at what answer. That what number was it? Number 24. 24B. 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 20% only. Okay, I'll check on this question. I was careless. I didn't see the answer not inside here. Answer 24 is B, you know. Let me look again. 24 is B. So small. Mm. By what percentage the overall number of frog change? Overall number of frog change. You got 100 frog here, 100 frog here, then 60 frog increase to 60. This one decrease to 40. So 60 and 60 is the change in the frog number of frog. 60 change over 200. 60. Okay, we go next question first. Tom wrote down several distinct positive integer, not exceeding 100. Their product was not divisible by 18. At most, how many numbers would he have written? As many as possible. So there is a strategy, not divisible by 18. We look at set of numbers not divisible by 3. And then our set of now divisible by 3, and the other part not divisible by 3. So we count those not divisible by 3. Yeah. Those divisible by 3, 3, 6, none until 99. So 33 numbers divisible by 3, not exceeding 100. So if we subtract all divisible by 3, you get number not divisible by 3. Question 1, not divisible by 18. So not divisible by 3, guarantee not divisible by 18. We look at the product. 1, 2, 4, skip. 5, skip. All the multiple of 3, we skip. So this product, their product not divisible by 18 one. They not divisible by 3, so definitely not divisible by 18. But you notice answer 67 is not inside here. Yeah. So this will make you think hey, why no 67? Each factor is not divisible by 3. Hence, the product P is not divisible by 18. There's no 3 inside. There's no 3 inside. 18 is 2 times 3 times 3. 18 must have double 3. So that makes us realize we can allow 3 to be included as a factor in the product. It will still not divisible by 18 because 18 require double 3. If we allow 1 3 inside, no have 18, no have multiple of 18, don't have. So at most 67 plus 1, 68 numbers are in their product. Okay. So the correct strategy is to think about divisible by 3. If you think divisible by 18 for a while, I also do that. Then like very confusing already. So why not one at a time? Not divisible by 9, can or not? Not divisible by 18, then and realize that the product important is to think the product. Number 16. Any three vertices of a cube form a triangle. Okay, choose 3 points, you get a triangle. What is the number of all such triangle whose vertices are not all in the same face? So one face is the square. You can choose 3 points. 4 choose 3. 1 point is out. So every time 1 point out. So 4 cases. Calculate triangle with vertices all in the same face. All in four vertices in the same face. 4 choose 3 or 4 choose 1 to take out. So 4 choose 3, but 6 faces. So 6 times 4, 24 triangle. All these will have vertices in the same face. But we want not in the same face. So we calculate the total. Total, we have 8 vertices. A cube has 4 points at the bottom, 4 points at the top. 8 vertices. If you choose any 3, then you get triangle already. Some are in the same face, some are not in the same face. Any 3 vertices form a triangle. Total number of triangle, 8 choose 3. 8, 7, 6, 3, 2, 1. This is the formula. If I can explain this formula, if you want, if you know already, it's very good. So 56. 56 minus, this is the total, minus those with the same face, so get the balance, not in the same face. Exclude all triangle with 3 vertices all in the same face. In the same face. So 32, answer 32. I explained the 8 choose 3. 8 choose 3. Suppose you got A, B, C, D, E, F, G, H, I. 8, A, B, C, D. So if you talk about 3, arranging 3 only, you want to arrange 3. So the first one, 8 choices. Second one, 7. The third one, 6. This you arrange. But you say choose only, no arrangement. No arrangement, so you got 3 objects only. 3 objects only, then 6 arrangement. And you take 3 and arrange one. But you say ABC same as ACB, same as BCA, so all 6 arrangement, 3 times 2 times 1. So this no arrangement, 8 choose 3. So we say this one is 8 choose 3. So this is why people always calculate by this method. But we can introduce something, the formula. See, formula will be, you got 8 times 7 times 6 already. Then you say I continue 5 times 4 times 3 times 2 times 1. Then you got 3 times 2, 3 times 2 times 1 already. But you add 5 times 4 times 3 times 2 times 1. What happened? So this create the formula in factorial notation. The top will become 8 factorial. Then the bottom become 3 factorial. And then 5 factorial. So this is a formula, 8C3 is 8 factorial, 3 factorial, 5 factorial. So the 5 factorial is redundant, cancel off. So 8, 7, 6, 3, 2, 1. That's how you should understand. How to understand? You try to arrange first. Then you divide the arrangement. Then you choose. Okay, that I thought this. I'm not sure whether long ago or what. So it's good to go over the reasoning. Number 17. Okay. In the picture, PT is a tangent to the circle, let's PT, with center O. PS bisect the angle TPR. Calculate the angle TSP. So the first thing, I draw a bigger diagram. Then because this is a diameter, the center O. So you can say center O, so means we have diameter. Diameter, the angle in the semicircle, 90 degrees, straight away 90 degrees there. Then you show this triangle, the angle in a semicircle, 90 degrees. Then I mark the angle SS. You want to find S, so then this U, then bisector, so P, the bisector, the angle equal. Then this angle in the alternate segment, and opposite segment. This one is in the minor segment. This one is in the major segment. This equal, angle in opposite segment equal. I don't want to prove lah. You may learn this already. Then another the V, also opposite segment. This small segment here, and then this one is in the large segment. Okay, all this is because the tangent, because tangent make angle in the minor segment, and the angle in the minor segment always equal the angle in the opposite segment. Then we show this triangle. We focus on this yellow triangle, then we form the equation. S is exterior angle, P plus V, interior opposite. Okay, equal S equal to P plus V. Then we close the triangle, then we show the green triangle. U is P plus V. Exterior angle of a triangle, equal to interior opposite. Okay. So S equal to U. But then this triangle is 90 degrees. S equal to U. S plus U also 90. So S equal to U is 45. Answer 45. Okay. Geometry. Next question. Consider the set of all 7-digit number that can be obtained using for each number all the digit. Must use all the digit. Cannot repeat. 7 digits, 7 different digits. List the number, list the set. We have a lot numbers, so must list the set in increasing order. So the first one is 1, 2, 3, 4, 5, 6, 7. That's the first one. The last one will be 7, 6, 5, 4, 3, 2, 1. Increasing order, the biggest is 7, 7, 6, 5, 3, 2, 1, like that. And you want to split the list exactly at the middle into 2 parts of the same size. Okay. What is the last number in the first half? Like that. So you make a list. If we got 100 numbers, then you divide into 2 parts, 50, 50 like that. So it means you have to count how many numbers first. Count how many numbers first. 7 factorial, 5040. Divide into 2 half equal. So one upper half, 2520 numbers. We want the last number in the upper half. The lower half, no need to bother already. So if you look at the number, you all think for a while. I need to go toilet. Yeah, I'm back. So you want the first 2520 numbers. So we study it for a while. Like that. 6 factorial times 3. I fix the first number. So arrange the last 6. So the first number, of course, 1, and then the rest move around. Then the second number, 2, then the third number, 3, the third group. The one half, we can go until 1, 2, 3. We got 2160 numbers. When you start with 1, we can move the 6-digit, 6 factorial, 720, all starting with 1. Then all starting with 2, another 720. And all starting with 3, another 720. So 2160. Still cannot reach the 2520. 360 more to go. We show this. We finish all the 1, 2, 3 already. So the next starting number is 4. See? Then we must have 4, 1, and then five numbers. 4, 2, 5 numbers. 4, 3, 5 numbers. This one will be 120 each, 5 factorial. 120, 360. We reach the last number already. 360. So the last number start with 4, 3, 1. So either D or E only. Of course, the last number is the largest. Must start with 7. 4, 1. This one I show. If you start with 4, 1, then 2, 3, 4, 5, 6, 7, until the largest 7, 6, 5, 4, 3, 2, like that. Just to double sure, to help people understand only. Start with 4, 2, then start with the smallest, 1, 3, 5, 6, 7. Then the biggest start with 7, 6, 5, 4, 3, 2. When you start with 4, 3, 1, 2, 3, 1, 2, 5, 6, 7, and then 7, 6, 5, 2, 1. So 120, 360 already. At this one just now, start with 1, 2, 3, 1. This one all start with 4. So we reach the maximum 2160. So the answer is E lah. Okay. 4, 3, 7, 6, 5, 2, 1. The last number always in order, decreasing one. The largest is decreasing 7, 6, 5, 4, 3, 2, 1. So any group largest must be decreasing order one. Okay, that's 28. Now 29. Okay, you got ABC, a triangle, such that AB equals to 6, AC equal to 8, and BC equal to 10. 6, 8, 10. And the M is the midpoint of BC, M the midpoint. AMDE is a square. We have got a square. MD intersect AC at F. Then find the area of the quadrilateral, which is shaded. So I draw a bigger diagram. Then label. Draw this line first. Then label. Okay. The triangle has here 10, 6. The 8 is here. I put outside. 6, 8, 10. 6, 8, 10, 90 degrees. 90 degrees, then M is midpoint. So that means angle in the semicircle. That means the radius is 5. Then the square side is 5 already. Angle in the semicircle. M is the center of the circle. So you want to find X. If we can find X, then we can find the trapezium here, the short side of the trapezium. This long side is 5. So how to find the short side, the x? Uh, because it's circle, important to know is a semicircle. So radius equal to the two angle equal theta theta. It's isosceles triangle. Then using this theta, tangent theta is 6/8. 6/8. Opposite over adjacent 6/8. But for this angle, x/5. So we form equation tangent theta 6/8 equal to x/5. So we can calculate x, which is 15/4. Then we find the short side, 5 minus 15/4, because this is also 5. The opposite side, 5 also. And trapezium, sum of parallel sides, opposites, long side 5, short side 5/4. The distance between them is 5. 125/8. Answer B. Okay, last question. 2,014 persons in a row. Each of them is a liar who always lies, or a knight who always tells the truth. Each person say there are more liars to my left than to my right. Everyone say the same thing. There are more liars to my left and than to my right. How many liars are there in a row? So this type of question, we can easily think that 2014 is just a number only. You can try like 6 numbers only, 6% only. No need so many 2014 like that. So we try layer 1, layer 2, layer 3, night 1, night 2, night 3. Then if we look at night 1, layer 1, layer 1 say more L to on my left than K, which is correct. Which is false, sorry. 0. On the left is 0. On this right got 2. So you say more is lying. So L1 is liar. L2 got 1 liar on the left. And then got K, 3K on the right. So L2 is also lying. Person number 2 is a liar. So I put L2. False. If we talk about K1, more L on my left than K. The K1, 3L, 2K only. So K1 is saying something true. So K1 is a 9. K2 also, more L to the left, 3L. And then only 1K on the right. So true. So K2 is a 9. So after you study this short example, we can say they are lined up like that. 1,000 liars on the left and 1,007 knights on the right. And every liar have less liars on the left than knight. And every knight has more liars on his left than knight. The answer is C. How many liars in the rows? 1,007 liars. Okay, that's the end of today's lesson. Right, stop share.